An athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minute 20 second? So the question is quite simple. We have a person running around a circular track. So we are looking at what is the displacement at end of 2 minute 20 second. So let us write the given first. Let me start from here. So we are looking at the radius being 100 meters, right? D by 2. Actually, I should go with that. D by 2, which is okay, 100 meters. And time for completing one round, time period is equal to 40 seconds. Then we have what is distance covered? Okay, so distance S at t is equal to 2 minute 20 second. So the time period is 2 minute 20 second. If not, if you guys are not okay with all of this writing, you can just write S at t is equal to 2 minute 20 second is what they are asking. Displacement. Okay, so let's discuss. I'll put the answer in a technical manner. I won't do a lot of calculation, only little calculation, but we'll use the idea or the concept or the funda. See, when you are going around a circle, you're back at the starting point every 40 seconds, right? That's what they're given. So this might be of any diameter or any length, it doesn't matter. For every 40 seconds, the person is back at the starting point. So this would start at every 40 seconds. Does that make sense? So we just have to look at where the person was just before 2 minute 20 second. So first let's work out the time. So t is equal to 2 minute 20 second. So this is 2 into 60 plus 20, and this is 150 second, right? So this is not 50, sorry, 140 second. This is what the time would be in seconds. Now let's talk about the next part, that is what happens to the athlete with reference to this time. So to begin with, as the athlete is running in a uniform rate, the displacement would be what? The displacement would be equal to 0 when every 40 seconds. So let me put it in this manner actually. Running in a uniform circular manner, in a uniform circular motion, the displacement will be equal to 40 seconds, right? Then we'll talk about this time period. The athlete at 140 second, which is equal to 120 plus 20 second, which in turn is equal to 2 into 3 into 40, right? 3 into 40 plus 20 seconds. I hope this made sense. He or she would have passed. She or he would have passed the start point 3 times, right? 3 into 40. So every 40 seconds, the person would have been at the start point 3 times. 3 into 40, 3 times, right? And the remaining time is 20 seconds. So we have to just look for what happens to the athlete in the next 20 seconds. Thus, in 20 seconds, the athlete, let me go down, would have ran. So now a bit of calculation, time, and this is path covered or distance covered. So to find where the person is, we need to find how much distance the person has ran. So that is 40 for every 40 seconds, one complete round, so 2 pi r. So 20 seconds where the person would be. So simple cross multiplication, x is equal to 20 by 40 into 2 pi r. So this would be 1s are 2s are 2 and 2 pi r. So what is this value? Pi r is nothing but one complete rotation. So this implies, not sorry, complete half a rotation. This implies the person has run half the track, half the path. And so what is the displacement? If the person is run half the path, the person is over here, the displacement would be equal to diameter. That's it. Displacement would be equal to the diameter. So this would be 200 meters. A lot of writing, yes. The presentation has to be this to make someone understand. If not, to be frank, as an MCQ question, it won't take more than 10 seconds. Honestly, 10 to maybe a minute maximum. But yes, writing part is a bit lengthy over here, but most of the time this is asked as an MCQ question itself. Anyways, we have to write it when we have to write it. There's no other option. So this is your answer.